So we've looked at calculating the equation of a plane. What I'm going to do here, I've got a couple of examples for you. I want you to read the question, pause the video, have a crack at them, and then come back and check your answer against what I'm going to present to you here. Here you go. So I've just got two questions for you. One, I've got an equation of a plane containing 3 points, and the second one's an equation of a plane through a point with a normal vector given. So pause the video and have a crack at those. So the first one was find the equation of the plane containing the 3 points A, B and C given here. Now, this one is quite similar to if we were given two lines, two vectors upon the plane. So let's imagine I've got my plane here, and there's my 3 points, my A, my B and my C. Now what we know is the normal to the vector is the vector product of two vectors at the point of intersection. So if I was to take these two lines here and do a vector B to A and a vector B to C, if I took the vector product of those, that would give me the normal to the plane here, N, and then what I've got is the information that I can use to calculate the equation of the plane, because I've got the normal and the point B, which I know is on the plane for certain, because that's where the two vectors intersect. Okay, so I'm going to use all that information to calculate my equation. So first thing I want to do, I've got my two vectors B to A and B to C. Before I do anything, I need to calculate those. So my vector BA is going to be given by the position vector of A minus position vector of B. So that's given by the coordinates. So what that's going to be given by is -2, 1, 2. Take away the B, which is 0, 2, 5. So what that means is I'm going to get a vector B to A given by -2, -1, -3. I then calculate my vector B to C. That's going to be given by the position vector of C minus position vector of B. So that's going to be given by 2, -1, 3. Take away the position vector for B, 0, 2, 5. So that's going to give me 2 minus 3 minus 2 as my vector B to C. What I then want to do is calculate my normal. Let's call that A. So that's going to be my normal to the plane. And that's going to be given by the cross product of BA and BC. So that's going to be given by the vector product of those. So what I now have to do is calculate that. And we know how to do that because we've covered it enough. Write my matrix with my I, my J and my K, plus, minus, plus. Then put my two vectors in, BA then BC. So I've got -2, -1, -3. And then I've got 2, -3, -2. Calculating each of these wee parts, I've got -1, -3, -3, -2 in the I direction. It's then going to be take away in the J direction, -2 to -3, -2. And then in the K direction, it's -2, -1, 2, and -3. So if I calculate each of those bits out, I'll end up with 2, take away 6. So I'm going to get -4i. I've then got -2 times -2, which is 4. 2 times -3, which is -6. So 4 minus -6. So 4 plus 6 is 10. But it's a minus in front, so it's then going to be minus 10j. I've then got this one here. So that gives me 6. Take away -2, which gives me plus 8k. So that's me now got the normal vector here. So what I've got to remember is my equation is a dot p equals a dot q. Now remember, in this equation, p is an arbitrary position vector for a point on the plane. So that's my x, my y, and my z. Q is the given point, and the a represents the normal. So if I substitute all the bits in together, what I know that means is I've got -4, -10, 8, scalar product with x, y, and z. That's going to equal my -4, -10, 8. with the scalar product of an arbitrary point q, but in this case what I'm going to take is q, the arbitrary point being the b, where the two vectors intersect, so it's 0, 2, 5. So if I calculate both of those, what I'll end up getting is negative 4x minus 10y plus 8z equals, well, negative 4 times 0 is 0. I then get negative 20. I then get 5z, which are 40. So I get negative 20 plus 40, which is equal to 20. So there you go. That's the Cartesian equation of that plane containing those bits of information. My second equation was finding the equation of the plane through negative 1, 2, 1 with a normal vector of I minus 3j plus 2k. Now this one's much more straightforward because we've got the information of a point and a normal on the plane, so we've got all the information that we need to be able to substitute into our a dot p equals a dot q. So my a is my normal, and in this case that's going to be given by 1, negative 3, 2. And my p is just the arbitrary point again, remember that's just x, y, z. And my q is the point on the plane, position vector of that point, which is negative 1, 2, 1. So plug all this information together into here, and what I end up getting is 1, negative 3, 2, dot with x, y, z, equals the normal 1, negative 3, 2, scalar product with the q, which is negative 1, 2, 1. So calculate both of those and we're laughing. So we get x minus 3y plus 2z equals, well, I get negative 1 from that first bit. I've then got minus 6 and then plus 2. So negative 1 minus 6 is minus 7 plus 2 is negative 5. So there you go. That's the equation of that plane through that point with that normal vector. It's not a difficult process. You just have to remember to take the information you've got and get those two key elements of that plane such that you can get the equation. Ultimately, we always need the normal, and ultimately we always need some form of point on the plane. The hint I would give you is if you're given the 3 points or the 2 lines, look at the point of intersection of those lines, or the point of intersection of the 2 vectors that you make using the 3 points in 3-dimensional space. That'll give you everything you need to know and everything you can calculate, and then you're laughing because you've got all the stuff you need to get your equation of your plane.